Morning to one and all. My name is Sheikh Mohammed Iqbal, and today I'm going to give a OS seminar about file system implementation in operating system and allocation methods in operating system. First, let us discuss what is file operating system. I mean, file implementation in operating system. A file is a collection of related information. The file system resides as on secondary storage and provides efficient and convenient access to disk by allowing data to be stored, located, and retrieved. File system implementation is an operating system reserves the file system that storage retrieval of data on a physical storage device such as hard drive, solid state drive, and flash drive. The file system implementation includes several components including file system structure. The file system structure refers to how the files and directories are organized and stored on the physical storage devices. These include the layout of file system data structure such as the directory structure, its allocation table, and the nodes. File allocation. The allocation mechanism determines how files are allocated on the storage device. This can include allocation techniques such as contiguous allocation, linked allocation, indexed allocation, or combined of these techniques. Data retrieval. The file system implementation determines how the data is read from and written the physical storage. These include strategies such as buffering and caching to optimize file I/O performance. Security and permissions. The file system implementation includes features of managing file security and permissions. This includes access control list, ACL file permissions, and owner management. Recovery and fault tolerance. The file system implementation includes features for receiving from sound system failure and maintaining data integrity. These include techniques such as generaling and file system snapshots. The file system implementation is a critical aspect of an operating system as it directly impacts the performance, reliability, and the security of the system. Different operating systems use different file system implementation based on the specific needs of the system and interrupted use case. Some common file system used in the operating system includes NTFS and FAT in the Windows and external for and XFS. Let us discuss file allocation methods. What are file allocation method? Allocation method defines how the files are stored in the disk blocks. These are three main disk spaces or file allocation methods: contiguous allocation, linked allocation, indexed allocation. The main idea behind these methods to provide efficient disk space utilization, fast access to the file blocks. So let us discuss the first one, contiguous allocation. In this scheme, each file occupies a contiguous set of blocks on the disk. For example, if a file requires n blocks and it is given a block B as a starting location, then the blocks assigned to the file B plus 1, B plus 2, B plus n minus 1. This means the given starting block address and the length of the file in terms we can determine the block occupied by the file. The direct entry for a file with contiguous allocation contains address, starting block, length of the allocated portion. The file mail in the following figure starts from the 19th block of the is equals to 6 blocks. See here we have given this. Count from 0 to 2, length 2, and tr 14th to 16th 3. Mail from 19 to 24 means 6 blocks we have allocated to the disk. List 28 to 31 4 blocks are allocated. So this is the contiguous advantages of the contiguous memory allocation. Both the sequential and direct access are supported by this. For direct access, the address of the kth block of the file which starts at block B can easily be obtained as B plus K. This is extremely fast since the number of seeks are minimal because of contiguous allocation of file blocks. The method suffers from both internal and external fragmentation disadvantages. This makes it inefficient in terms of memory utilization. Increases file size in difficult because it depends on the availability of the contiguous memory at a particular instance. Let us move to the next one. Linked file list allocation. In this scheme, each file is a unlinked list of disk blocks which need to be contiguous. The disk blocks can be scattered anywhere on the disk. The directory entry contains a pointer to the starting and the ending file block. Each block contains a pointer to the next block occupied by the file. The file zip in the following images shows how the blocks are randomly disturbed. The last block 25 contains -1 indicating as a null pointer and does not point any other block. See, we have given this example. Here ending is denoted using -1 and starting is denoted using 1. The file name is zip and starting from 9 and end at 25. Advantages of the Linked list allocation. This is very flexible in terms of file size. File size can be increased easily since the system does not have to look for the contiguous clunker of the memory. This method does not suffer from external fragmentation. This makes it relatively better in terms of memory utilization. Disadvantages. Because of the file blocks are disturbed randomly on the disk, a large number of seeks are needed to access every block individually. This makes linked allocation slower. It does not support random or direct access. We cannot directly access the blocks of a file. A block of files can be accessed by traversing k blocks sequentially from the starting block of the fill via block pointers. Pointers required in the linked allocation incur some extra overhead. So let us discuss the last allocation method, indexed allocation method. In this scheme, a special block known as index blocks contains the pointers of the all blocks occupied by a file. Each file has its own index block. The ith entry in the index blocks contains the address of the ith file. The directory entry contains the address of the index block as shown in the image. See here 19 is the index block. It contains all the allocated blocks indexes in it. We have given the name of the file as G. Advantages. This supports direct access of blocks by the files and therefore fast access of the file access. It overcomes the problem of external fragmentation. Disadvantages. The pointer overhead is indexed allocation is greater than the allocation. For very small files, says file that expand to 2-3 blocks, the indexed allocation would keep one entire block. For the pointers, which is inefficient in terms of memory utilization, however, in linked allocation, we lose the space for only one pointer per block. For files that are very large, single indexed block may not be able to hold all the pointers. Following mechanisms can be used to resolve this. Linked scheme. The scheme links two or more index blocks together for holding the pointers. Every index block would then contain a pointer and or the address of the next index blocks. Multi-level index. In this policy, a first level index block is used to point to the second level index block, which in turn points to the disk blocks occupied by the file. This can be extended to 3 or more levels depending on the maximum file size. Combined scheme. In this scheme, a specialized block called the inode information node contains all the information about the file such as name, size, authority, etc. And the remaining space of inode is used to store the disk block addresses because contain the actual file as shown in the image below. The first few of these pointers in inode pointers point to indirect blocks. Indirect blocks may be single or indirect, double indirect or triple indirect. Single indirect block is a direct block that does not contain the file data, but the disk address of the blocks that contain the file data. Similarly, double indirect blocks do not contain the file data that the disk address of the blocks that contain the address of the block containing the file data. Thanking you for giving me this opportunity.